of lightweighting that is enabling the industry's shift towards sustainability. As we all know, the automotive industry is undergoing a radical transformation driven by the twin imperatives of reducing environmental impact and meeting stringent emissions and safety standards. Lightweighting, therefore, has emerged as a key methodology to slash vehicle weight and meet emission regulations such as the Corporate Average Fuel Economy or CAFE norms, which we all know, which are governing the Indian passenger vehicle and several other markets around the world. The lightweighting strategy not only enhances the fuel efficiency and reduces vehicular emissions, but also contributes to the overall vehicle performance and its safety by use of several innovative materials, such as high tensile steel that improve crashworthiness despite being lighter. During this webinar, we will touch upon all such aspects, some of the key drivers of lightweighting, the design strategies being adopted by OEMs, advanced manufacturing and material techniques, as well as the limitations of this technique for optimizing vehicle weight. The event will have a series of panel discussions and one-on-one conversations, enabling all of us to learn from experts about the industry's roadmap to sustainability by virtue of. My name is Mayank Dhingra. I am the assistant. The member of the executive committee at Maruti Suzuki India and the former CTO of India's largest car maker. Raman-san will make a presentation followed by a small Q&A session. So if you have some questions through his presentation, please feel free to type them in the chat box and I will take them with Raman-san once his presentation gets over. Raman-san, over to you, please.
So good afternoon, everybody, and first of all, thank you, Mayank-san, for the introduction. And is my screen visible? If you can confirm that.
Yes, Raman-san, it's visible. You can go on a full screen mode on this. Yes.
So, Mayank-san, so thank you for inviting me and thank you for having me. I hope the slide is in proper format.
Yes, absolutely. Yes.
Okay. So, what I would like to do is that I have a very short presentation, and then I would like to go through that, and then if there are any queries, questions, and we can take that from there. My name is C.V. Raman. I am the member of the executive committee of Maruti Suzuki India. And I will be talking about automotive lightweighting and sustainability. So just to set a little background and context, climate change conditions and COP related discussions have been driving world over towards a net zero imperative, and and that's because of the rising global temperatures, and all of us are aware of that. And so, world has decided that net zero a target of 2050, whereas India, because of its own imperatives, has declared that India will be net zero in 2070. Of course, we have various enablers and which we are doing, which is in terms of renewables, in terms of renewable energy, as well as reduction of the carbon emissions, and also from the intensity. As you're all aware, 2005 was the starting year, and when we sometime back had our INDCs, we had said 30%, but now, last year this has been up to 45% from a carbon intensity perspective. So, of course, in addition to all of this, India has its own set of very unique challenges, and that's, I think, something which we all need to keep in mind. And we are a developing economy. Our GDP per capita is increasing, but however, it is still about 1/8 or 1/9 of advanced countries. We have a very high congestion rate, even though our motorization level for a passenger vehicle is low, but we have a lot of other uh, 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 mobility solutions which are running, and we have a lot of congestion, and our infrastructure is increasing. But today, if you still see, we have two of the top five cities in the world are of India as far as the congestion is concerned. High pollution is something we all know, and especially in the Gangetic Plain, people are well aware of the issues which are there. And India is a very large importer of the crude oil. Almost 88% of the crude oil is imported, and which is a large portion of our import bill. And lastly is, of course, the high accident rate in India, which is uh, something which is a cause of concern for all of us. So there are many dynamics which are changing. The India is changing, the customer is changing, the requirements are changing, and the mobility technology is also changing. So if we look at, we already talked about carbon neutral India, and 2070 is our target. We also have a very ambitious target to make India a Vikasit Bharat by 2047, and targeting a $32 trillion economy, and manufacturing share in the GDP to reach 25%, and auto sector share in GDP also to increase to 10%. We are targeting to be the third largest economy by 2030. We have a very good demographic dividend, and we have a young population. And technology adaptation by India is very, very strong, especially from a connected and the digital technologies which are there. I talked about the customer. We have a young population, and one of the youngest in the world. And that is something which is driving this growth. Digital and connected India, we are well aware of the potential and the leverage which India has used for this, and the internet usage, the smartphone usage, and so on and so forth, is one of the largest in the world. And what it has done is that it has made the population of India, the young customer of India, very well aware of whatever is happening globally. And that is leading to what is the requirement today of the customer. And customer is, looking for a vehicle which is having futuristic design, which is very, very appealing. Customer is looking for safety. The perception towards safety has increased tremendously. And also the adaptation of new technologies and modern technologies in terms of HMI or connected or personalization, and premierization of some of the features. That is something which today's customer is aspiring, right from the the lower end to the higher end. And as we also are seeing, the share of other mobility options is also increasing. There are emergence of new mobility options, and from a sustainability perspective, I think it's very, very important that in the next 10 years or 15 years, there is going to be a change in the landscape, and mobility is going to evolve, and multimodal transportation and such initiatives are going to gain ground. Uh, Regulations are ever changing, and we have seen that in the last 7 years, there has been a slew of regulations both on the safety side, on the emission side, on the cafe side. All of that is happened, and that has had some kind of an impact because of the kind of customer which we have got. The affordabilities do get impacted to some extent, and that depresses some of the demand at the lower end. And but this is something which we are going to see that in future too. There is a lot of talk on future technology, future regulations in terms of safety as well as emissions. And Mayank San did mention about cafe. Cafe also is one main driver. And Cafe 2 has just kicked in last year. last year 2022, and the next phases are going to come in 27 and so on. And there are the safety regulations also being talked about, and BNCAP has also been now notified. So all of that is is increasing the cost weight, and also the development, the time is increasing, and also the complexity is increasing. And we all know that the regulations, because of our intensity, emission intensity, and also from a imperative uh, uh, for the greenhouse gas reduction, we need to, there will be some stringency which is there. But we need to look at not just from an efficiency perspective, but we need to look at overall greenhouse gas emissions, how we can do and what is that we can do. And that's something which I would like to talk about in the next couple of slides. If we compare, the India and the Europe GHG emissions, and there is a lot of variance which is there. In India, the GHG from transport is about 13%, whereas in Europe, it is almost 29%. It is more than double. Passenger vehicles constitute just 2.2% of the GHG in India, whereas in Europe, it is 15%. So I think why I put this slide is that uh, there is a need to understand this from the overall GHG perspective, and also the emissions, from the transport sector being lower, and also the unique requirements of India and challenges of India. We need to have India specific and regulatory mechanisms, as well as enablers, and also see what is available in India to be able to still move around in a sustainable way while developing the economy. So the approach is what I believe is important. And so we would all like to achieve sustainability and reduce the greenhouse gas. So from a product emission perspective, there are two aspects. One is on the drivetrain technology, and the second is on the vehicle side and on the material and other aggregates. So on the drivetrain technology, I think it's we are all working towards various initiatives along with the government. The government is looking at a gas-based economy. The government is looking for a grain to fuel economy through the ethanol program. E20 will be, all vehicles are today material compliant. 2025, E20 will come in pan-India. And we are, therefore, we are promoting alternate fuel. We are seeing a lot of electrification of the ICE powertrains through hybridization and electrification. And also, traditional ICE engine technology improvement is also being worked on. It's not that, no work is happening on that. And so that's something which we all need to work. The second is about the, vehicle material. We need to use environment-friendly material, recyclable material. We need to reduce the weight. And why we need to reduce the weight is because of our imperative that if we have to reduce the CO2 and improve the overall efficiency, with the new technologies coming in, the vehicle weights are increasing, and there is that much improvement which has to be done on the vehicle side too. And therefore our imperative and today's topic of discussion is how do we do lightweighting in order to be able to gain better efficiency and still reduce the CO2 and look for new generation materials and so on. And that's what we'll talk about. And overall, when we look at this from a overall ecosystem perspective, we also need to look at the operational efficiency and the ELV of the entire life cycle. And so that's something also which is going to impact and reduce. If we work towards that, it will reduce the GHG overall. So, when we look at the paths for GHG, and I did mention this, that we are looking at multiple pathways of working on ethanol and flex fuel. We are working on CBG, that is waste to fuel. And that's one new direction which the government is looking at. CBG plants are being increased across, and 5% blending is now being talked about. And we're also looking at electrification going forward, and various percentages of electrification are being talked about. And that's something which we all need to work and create that ecosystem for moving towards that. And all of this is resulting in reduction of GHGs and forex savings of 41,500 crores, and of course, improving the farmer income. Recently, last year, the Global Biofuel Alliance was also, was launched in India, I think, and that's giving a very clear direction from the government side to work on the alternate fuel strategy for India. So that was from a powertrain side, but now the topic of today's discussion, we need to work on lightweight material, which will help us to meet the future CO2 requirements. And the weight reduction on the vehicle aggregate side is very, very important. So if you look at what are all the vehicle aggregates which are there, and you have all the vehicle aggregates here, which we have put up, from a body side, from powertrain side, from the seats, interior, and the suspension, the chassis related, body, which is a large component, and of course, for electrification, the battery. And as we are looking at higher, ranges, the battery sizes go up, the battery sizes go up, the overall weight of the vehicle goes up, and also, if we have to meet all the, safety regulations, and also ensure that the battery pack is safe, we need to also ensure that the vehicle structures need to be strengthened in order to, ensure that the energy absorption and is better, so that the occupant safety is also kept to the same level, or even better going forward. So I think we need to look at all the aggregates in the vehicle towards lightweighting. So from material side, we have advanced high tensile steel, ultra high tensile steel. All of these are being used today by manufacturers to achieve the overall weight reduction without compromising on safety and efficiency. We are also looking at, from a body side, because one is, of course, the aspiration of the of the customer, and they are looking for better design. As I said, they are also looking for, the CD of the vehicles is also very, very important. The lamp design and the bumper design and so on and so forth. All the aggregates, we need to make them, more sleeker, and reduce the CD of the vehicles, which will eventually benefit the fuel efficiency, and reduce the CO2. And lightweight materials, new materials. We have to explore new materials, develop new polymers, composites, and also from a sustainability perspective, look at biodegradable materials. So this is the overall scope of lightweighting applications, which we all need to work on. And there are some other examples I will talk about in the next couple of slides. So recently, Maruti Suzuki launched the fourth generation of the iconic Swift. The first Swift was launched in 2005, and when we launched that, the platform was different, the powertrain was different, the design was, for the first time we had such a sporty vehicle, and at that, in that context, if we look at we had 147 gram CO2 in 2005, and today, after the second generation and third generation, after changing the platform, after changing the powertrain, and two times, from the G series to the K series, and now recently the Z series, design getting enhanced, more features getting added, we were still able to give a very good reduction in the CO2. And the CO2 is about 95.6 gram per kilometer for the all new Swift. So overall, a 47% reduction from 2005 to 2024, and a fuel efficiency improvement of about 50%, and The fourth generation Swift is lighter by almost 100 kg in this period of time. And that obviously means that we have been able to use a lot of alternate materials in order to achieve that. Just to give an example, this is the kind of, change which has happened from the previous generation to the new generation, as can be seen. The advanced and high tensile steel and the ultra high tensile steel is where the weight has further gone up, the percentage has gone up, but still yielded a lower, weight and improved the efficiency and the crashworthiness of the vehicle. And so these are directions which are there. And also, I would like to now talk about that we talked about electrification, and the electrification is also, in a way pushing, the envelope as far as the lightweighting is concerned. So what is happening is that the advanced high tensile steel and the ultra high tensile steel, that component, the difference between a ICE vehicle and the EV is very, very evident that the increase is very high. And so we are increasingly using more ultra high tensile steel and advanced high tensile steel. And this is something which is very important to be kept in mind when we are looking at EV technologies. The one thing we should all understand is that the lightweighting does not mean low safety. There has to be a focus on materials like magnesium and durable thermoplastic. And we have increasingly seen during the powertrain changes and such other aggregates, we have switched over from cast iron to aluminum to other alternates, composites, thermoplastics. And these are some of these things which we will enable to improve fuel efficiency and safety of vehicles. Now, what does it mean as far as the future is concerned? We all know that there is manufacturers today in the US and China who are looking at a totally different way of manufacturing electric vehicles, and the electric vehicle imperative is even more important because of the additional weight the battery pack carries. And so two-pronged approach. One is to reduce the production cost and also reduce the overall weight. And so example is Tesla Model 3. It has about 171 metal pieces, traditional joining methodology. And now the Tesla Model Y with a gigacast and battery pack, part of the platform. That is the direction which has done two things. One is it has reduced the production cost, and it has increased the efficiency of the on the assembly line, and also it has reduced the weight significantly. Of course, these are examples, at a very, very high-end model where this is affordability is possible. But this is a direction definitely, and in future, if technology cost and productionizing cost comes down, this can get democratized in future and come to India. Similarly, there is another recent example of another global product which showed that 72 components got integrated into one and reduced the welding joints, also weight reduction of overall 17%, and improved the dB level and of course overall productivity. And so this is, I think, one definitely one direction which one would see going forward in the next 10 years. That gigacastings direction is also one thing, as in when the EV fleet and the volumes grow. Other examples which one would look at is both on the front end side, on the body side, under the hood, engine components, composite or plastic back doors, plastic fenders, and move towards biodegradable polymers for the seats, for the thermoplastic parts, and other aggregates. These are things which is definitely is going to overall reduce the weight. One other point which I would like to add here is, of course, on the electrical side, also going over from a traditional 12-volt system to a higher voltage system to reduce the overall copper content is also one direction which is now being talked about. And so for a engineer, it's always a dilemma. How do we reduce the weight, improve the performance, improve the rigidity, ensure the crash performance, NVH, and also reduce the CO2, yet keep it affordable? I think this pivot is something which is very, very important for all of us to understand. And that's a big challenge in front of all of us. And I think engineers will be working for, looking at alternate materials and looking at various initiatives in order to overall reduce the weight of the vehicle. Last couple of slides, I talked about the ELV end of life and about the processing, where the GHG reduction can also happen. How we can, have RRR, reduce, recycle, and reuse, philosophy in our vehicles in our ecosystem, and how do we promote those practices? How do we ensure that a circular economy is built, and also how do we take care of waste at the end of it, especially when we are looking at a lot of EVs going forward. I think that is something which we also need to keep in mind, that in the next 10 to 15 years we need to build that ecosystem in order to be able to sustain and allow that products to come into the market. And so a collaborative approach is required all around in order to be able to, and get all the stakeholders on board to be able to develop this circular ecosystem. So definitely we need to work on India-specific R&D and local technology manufacturing and develop a recyclability infrastructure. And so I think it's very, very important that we need to have a balance of sustainable development and also take care of our needs without jeopardizing future generations, and move and develop products in a very, very sustainable way. So that's all I had from my side. Thank you all for your patient listening. I'm now open for any questions.
Raman-san, thank you very much. It was a lovely presentation, and you've covered almost all the points that, sort of make us understand that lightweighting is a key pillar of sustainability if we look at it holistically. And, what better example than, the Swift from the first generation to the fourth generation. I mean, 100 kg weight reduction is a notable weight reduction that you've achieved. And I've recently driven the car in Bangalore, and, I can vouch for the kind of chassis stability, the dynamics that you've been able to retain in that product, despite, going lighter on the weight. So I think fabulous. And touching upon some of the key regulatory drivers, I mean, CAFE 3, BS7, all these things are also going to require OEMs to stress upon lightweighting and, become more and more efficient in the products. So thank you very much. And I'll straight away jump to the questions. We've got a lot of questions out here. And the first question from Mr. Nishant Chauhan. Among the various safety and emission norms you called out in your slides, could you help us understand which are the ones which are going to have major impact on the cost of the vehicle?
There are many actually, and if you look at from the next CAFE regulations, is definitely going to be one direction where the cost is going to go up, especially because of the new technology development which needs to be done. But having said that, I think it's also need to be looked at from a fuel map and the energy roadmap which we are going to envisage for India. And what I was trying to say is a path where we can make it, still achieve the means, but still have affordable technology and not just one technology. So that's one point which is there. Second is, of course, on safety side, there are some technologies which are now being talked about. We are talking about, adaptive, advanced driver assist technologies, or AEB, being, in if fitted conditions and going forward. And those are aggregates which are today not available in India. And there is a challenge, of course, from a usage perspective also, because of the kind of traffic which we have got. And so those are all things which are there in, as because some vehicles are getting it, equipped with that. So regulation as such for testing them is being, talked about. When they actually get mandated, or they become part of some regulation, is, still under discussion. But yes, all of these costs, and also cyber security and some of these things, electrical architecture is going to change. All these are going to increase and impact the overall cost. And of course, from a customer perspective, customer really does not, want to pay for regulations. Then customer will pay more for the bells and whistles and the features which one is able to, get around comfort and convenience and so on. So I think yes, it is. It's always it's question of optimization going forward.
Right. I'll take the next question from Mr. Aditya Bansal. With the introduction of lightweighting solutions like employing aluminum knuckles and control arms in the European market, could we anticipate a similar adoption in the Indian market for the mass volume segment?
I think again, I think it's about, the technology is available and it's possible to be done. It's all about, what are you replacing it with? And when we talk about value analysis or, value engineering, one of the levers which needs to be kept in mind is that we should not increase the cost much. And so somewhere, some of these technologies, even though that they are available, they may not, get possible to be absorbed in the lower end of the vehicles. In the higher end of the vehicles, on the luxury cars, anyway, whatever is being imported or being assembled here, anyway, many of those aggregates are like that, knuckle and so on. But in the lower end, which is the volume segment, I think it's still early days.
Right. And Raman, your mention of gigacasting has had everyone excited. So people are really asking, how soon do you think that is going to come to India? And, will it be feasible for mass market OEMs in the Indian market?
There is definitely a Tesla car. Everybody knows the price of that Tesla. And cut to India, and we know the EV cost and the ICE vehicle costs which are there. So it's a huge difference which we are seeing. But having said that, why I showed that was only to just say that this is happening and this is possible. Now we are talking about possibility and possible approach, but whether it will, in what form and what part of it can be used. And today also, we, CNG, and I'll take this example of CNG, a composite cylinder, you can make a composite cylinder.
Mm-hmm.
The cost of this composite cylinder is more than double of a traditional cylinder. And so, whether for a CNG customer, it makes sense, even though the lightweighting is possible. Now, that's where the challenge is, and also a mass, productionizing of that and processing technology and all of that. So I think that is something which is a direction will definitely things will happen. So it will happen step by step. Some of these aggregates in some ways are likely to happen. Magnesium or aluminum castings could happen. But a gigacast itself, a complete thing, the entire production technology, evoking a change. I think it's still a long way.
Okay, right. And with that, Raman, we've completely run out of time, and really appreciate you taking out the time and giving us this really insightful presentation. And I think you've really educated a lot of us and brought up this gigacasting topic, for example, which is sort of a new thing for all of us to, it's a food for thought going forward, and we'll also do a lot more research on it. And I really appreciate. Thank you so much for your time.
Thank you. Thank you. Thank you very much. And thank you all for your patient listen. Thank you so much. And thank you for having me.
Thank you. And with that, we'll move to the next session, which is a panel discussion. And we have an eminent panel with us with Mr. Anand Kulkarni, Head of EV Programs, Tata Passenger Electric Mobility. Mr. Ritesh Agarwal, SVP, Head Sourcing, Auto Sector, Mahindra & Mahindra. And Mr. Srikumar S., Delivery Head, Automotive, Tata Elxsi. Gentlemen, thank you very much for joining us. And after that contextual setting by Raman San, I think we are all geared up for a good round of deliberations here in this panel. And first, I would like to just, throw it as an open question to all of us, maybe starting with you, Anand. Your broad points, your broad thoughts about, the importance of lightweighting, though Raman San, shed light on it, that regulatory requirement is one of the key drivers why we are going towards, this engineering methodology to reduce vehicle weight so as, the vehicles become more and more sustainable and efficient. So just a broad thought from each of you on the importance of this engineering methodology.
Hi, so Mayank, thank you very much for inviting me to this discussion today. And hello to Srikumar and Ritesh as well.
Hello.
So to the question that you've asked, Mayank, I think this goes back uh, in time to the fact that physics is such that if you have to propel a higher mass, you will always expend more fuel. And therefore, engineers always would want to try and see how do we optimize the weight of the car. Uh, as time has progressed, more materials have become available, more methodologies have become available, and therefore today we are talking about how do we deploy these materials in order to achieve that goal of a lighter, but at the same time, a stronger and no less robust vehicle, because we all need to have safer vehicles, we all need to have durable vehicles, and yet at the same time, we all need to have lighter vehicles for the reason that I said before. And this is this, ever ongoing pursuit of lightweighting. You talk about the 1970s, or you talk about the early 2000s, or you talk today. The goal has pretty much been the same. Of course, various technologies, various advancements in technologies have improved things. For example, what used to be very mechanical earlier is now mechatronics. It's a lot of electronics, so weight has gone down there. But eventually, I think we keep working on ways and means to do this. Therefore, it's a topic that has relevance at all points in time. And various generations of engineers have always utilized the latest advancements, the latest material technologies, joining technologies, bonding technologies available to them to be able to do the best out of what needs to be done. So that's the broader perspective, and I'm sure as we go on, we'll talk more about it. But I will hand over to my co-panelists to share their thoughts as well.
Sure. Mr. Shikumar, your thoughts on this?
Yeah. Hello to fellow panelists. Good afternoon and good afternoon all the audience there. So I think lightweighting is important because, as you know, people are always associating efficiency with weight. If you are lightweight, it means more efficient. If you look at the current powertrain itself, we think electric vehicle is the most efficient power propulsion technology available at currently, which means that you can't have a vehicle which you had for ICE engines for the electric vehicles. So how do you bridge the gap? So you need to definitely do some sort of an efficient way of working when you're particularly using something like an electric vehicle. So lightweighting helps us with that. And we are already seeing that people have started to actually look at lightweighting as a critical contributor for enabling electric vehicles. Still, we are a little bit far off as far as propulsion is concerned. But I think there are different materials and other aspects of lightweighting is already creeping into automotive sector, which is a welcome development. Thank you.
Sure. Mr. Agrawal, your thoughts, please.
Hello to the fellow panelists, and Mayank, thanks for inviting me over to the Zoom webinar. So as far as the topic of lightweighting is concerned, Mr. C.V. Roman has extensively spoken on the topic. As far as the drivers are concerned, I think the first one is the CAFE norms itself. The CAFE norms are becoming stricter by the year. We've seen how strict they have become in Europe. They've migrated from 113 grams per kilometer, which is the CO2 emission limit that they have put in. They have brought it down to 95 in the year of 2020, and it is going to reduce by another 15% in the next 5 years, which means by 2025. A similar trend has been seen in India. We are not at the same levels, but we have also come down from 130 to 113. So while the emission norms become stricter, which is guided as per the CAFE norms, the auto OEMs have to go beyond the customary techniques of doing the car after treatment. So lightweighting is the obvious choice to do it. There's no other method to do it. And hence lightweighting is important over there. We've seen that a 10% reduction in weight in the case of ICE vehicles gives you a 6 to 8% fuel efficiency. And in the case of electric, a 10% weight reduction gives you a 13% increased mileage that you get on the vehicle. The next thing is on the EV vehicles. EV vehicles, as you know, have the added baggage of battery and the high voltage systems, which increases the weight by around 350 kgs. Now, to counter that 350 kgs, which actually reduces your the single charge mileage that you get on the vehicle, you have to counter it by lightweighting, because there is an excess of 350 kgs that you need to counter. The third one is sustainable mobility. Now, the core, for sustainable mobility, the first thing is the scarcity of resource itself. Now, how do you counter the scarcity of resource? By consuming less. And for consuming less, you need to do lightweighting. So these are the three drivers towards lightweighting, which are important and core to sustainable mobility.
Right. And I'll stick with you, Mr. Agarwal. You've given your broad perspective on this, but from your standpoint as a sourcing professional, like Raman-san also mentioned in his presentation, the different materials that we are looking at going forward, the composites, the biodegradable materials, and all these things. So from your perspective, I mean, what's the impact on the cost that you're seeing on a per model basis? Is that becoming a bit of a challenge when engineering tells you that, we need to adopt alternative materials? So from your perspective, how is that gap being bridged right now?
So the cost challenge actually comes from the migration of lightweighting that you see. If you're migrating from a level of what you were doing, let's say in 2015, and coming down to 2020, in Mahindra, we've done a reduction of at least 200 kgs in our vehicles to meet the CAFE 2 norms that we are at today. Now, the technologies that we have used are a mix of aluminum and high tensile steel. We've gone to the level of UHSS steels. We've done a huge application of aluminum. We've done in the case of aluminum knuckles. We've also done plastic lightweighting with plastic tailgates. So we were the first to experiment with plastic tailgates and we achieved 20% reduction over there. We probably were the pioneers in introducing plastic in the case of fenders, which started with XUV5O.
Yeah.
So we've taken a lot of steps towards lightweighting and experimented with technologies which were not available in India at all. Obviously, they were available outside. Now, coming to the cost part of it, there is a level to which you can stay at the current cost with lightweighting. But beyond that, when it is guided by stringent regulatory norms, then you have to bear the cost. The thumb rule in Europe is $5 to a kg reduction in weight.
Okay.
So you have to very intelligently manage the costs. You can't really escape from an increased cost, but you have to intelligently manage it. The way to intelligently manage is use a mix of materials intelligently between high-strength steel, aluminum, plastic composites, magnesium, depending on the application that you're doing. And with this mix of material, you have to try and manage the cost. But yes, there'll definitely be a cost increase to it.
Right. Mr. Srikumar, your inputs on that, like Mr. Agarwal says that, I mean, a $5 increase in the cost is sort of agreeable for every kg of weight reduction. So from your perspective, how are you sort of giving your guidance to OEMs when they go about, managing these projects about reducing weight in their platforms?
So as far as we are concerned, we are looking at from the design point of view.
Yeah.
Right. So if you look at lightweighting design getting implemented, there is a process in which we have to take it through, right from concept level to design to validation, testing, prototyping, and basically getting into serial production. So I look at it multiple ways. Like in case of design, we look at from concept, we look at from material point of view. We look at the geometries of the materials also. Is basically the design and the manufacturing, right? So when we look at concept, again, we should make sure the replaceable part, whatever is doing at whatever cost it is going to come, cost comes a little bit later. And we look at it, whether it is going to do the same performance, it is going to perform the same way like the existing part. And if you look at the materials, obviously lesser dense and higher strength, we are going to look at that sort of a material. So these are the considerations. What I'm trying to tell is for the design, wherein we start looking at a replacement of part, getting it into discussions with the vendors to look at how to manage the cost, etc. And we're going to look at the geometries and manufacturing. So if you look at basically how do you go about selecting a cost benefit for a particular design, that itself is a big process. It is going, if you really want to be thorough, there is going to be a model you need to generate, which will include like fuel efficiency, fuel prices, expected rate of return for the company that is investing in the technology, annual mileage, technology type, non-fuel running cost, average load factor, etc. See, for example, in a truck, right? So if the weight reduction of 9% possible without any cost increase, while greater weight can be achieved at higher cost. For example, 500 kg reduction in weight at cost increase of $2,000 is something possible while maintaining the safety and performance. So that is what we are looking at. And of course, we are looking at different materials, which is giving different type of vehicle weight reduction. And there are certain aspects of design which people are focusing on also, which is very good, like use of fasteners, right? When your use of fasteners, that itself takes a lot of weight, and it is possible to replace those fasteners with a better judicious use of processes like gluing, adhesives, spot welding, laser welding, etc. Even though there is this incremental increase in weight, but it's not the same as the weight of fasteners as such. So if you look at the powertrain, for example, 48% of total weight of a commercial vehicle powertrain is powertrain basically. So you've got a lot of shafts in the transmission, wherein we are going to core it out, which is going to give a reduction of around 30%, 10 to 30% is what is going to be possible. We are looking at, again, buses and trucks, and the process what we do, or if you take one particular component, for example, for one of our customers, what we did is we took the driveline component, and which was basically already a hot pressed aluminum. We made it into a pressed component. The reason for that is looking at the weight and the performance characteristics more than the actual lightweighting part of it. But we have to take the call. We don't have a choice. But it is not done just like that overnight, right? So what we do is benchmarking, new concept generation, integration, kinematics, looking at the kinematics, clearance checks, load study analysis, weight cost analysis, DFM, DFA, all this DVP, and also validation, physical and as well as testing. So we do that go through the entire process to make sure that our decision is right. I would like to end with one new concept, that one thought process which can be effectively used, because we are talking about implementing new lightweight material into the design. But if you really look at it, how do you implement it into the design? There is going to be a cost for implementation. People are afraid of that because what is going to take? What is the timeline it is going to do? But with the new concept of digital twin, there is an opportunity for us wherein we can look at start the digital twin as we go about doing the design, validate that, and particularly for maybe doing certification, we can validate the component whether it is good for lightweight design or not. So this is the thought process we have, and hopefully the OEMs and others will take up this queue and will start looking at that. Thank you.
Anand, coming to you, you also mentioned this in your opening remark, how efficiency is so important in case of an EV. You have a limited size of the pack, and right now, to sort of increase the penetration of EVs, range anxiety is the biggest roadblock that we have to encounter, or that we have to overcome right now. So from that perspective, what is the strategy that you adopt when you look at, in your case, for Tata Motors case, for example, right now you have a ICE to EV conversion of a couple of your models like the Nexon or the Tiago. So what is the approach there? How are you able to manage this shift, and what is the engineering thought behind it when you're making this transition?
So, Mayank, first of all, we need to understand that the propulsion requirements are pretty much the same. What you need to therefore do is, and I think both Mr. Raman as well as Ritesh, both of them said that increase in mass of an electric vehicle is an important part that you need to handle. And as engineers, while we would want it to be as low as possible, there are things that you cannot change. So you always have to carry the mass of the batteries, and that often results into a 250, 300, 350 kilograms of weight increase. Now, let's understand that when the mass of the batteries comes on, there is a cascading effect into some of the other components. So, for example, if you would want to keep the braking intact as well, you would certainly need to touch the foundation brakes. You would certainly need to look at what is the bearing load on your tires or on your wheels, and so on and so forth. there could be other aspects that you need to certainly look at, which means how does the car behave in terms of its frontal crash performance with that additional mass. And let's say you are trying to therefore do this in the most optimal manner. You would do it. One is by what Sri Kumar described as design efficiencies or design competencies. So you would try and design the most optimal sections, the most optimal thicknesses to make sure that the entire structure is designed to be capable of taking those, absorbing those loads. Or there could be other things like you move on to advanced steels, advanced materials, which allow you or which free you to a certain extent from the constraint of a geometry and allow you to experiment with more complex geometries within the given framework or within the given constraint of a vehicle. So you have to really look at these things, and then at the same time, I think the role of aerodynamics is often understated, and that continues to remain one of the big challenges. And therefore, a lot of energy, a lot of effort, a lot of engineering man hours, man years, I might say, get spent in optimizing this to the best possible extent. Because if you can take away some of that resistance, and if you can take away some of the rolling resistance, which is where the tire meets the ground, then I think you get a big fillip in terms of your quest of better efficiency. And to a certain extent, I think that also has the ability to offset this cost versus material versus weight dichotomy that we engineers tend to have.
Right. So from that perspective, I mean, are some of these materials really allowing you to experiment with very futuristic shapes and designs on the exterior of the vehicle?
So there are a couple of things. There are materials today which will allow you to sort of do the same strength in lesser thickness or lesser mass. Advanced high strength steels, for example. Then there are materials which were considered exotic from a automotive perspective a generation back, and today they are finding applications, at least in certain high-end applications. You could talk about carbon fiber and so on and so forth, but more casually, you could also talk about plastics, for example. And aluminum is coming back in a big way. One of the things that we've got to always recognize is that while these materials are available and you may solve the cost versus the engineering expectation equation separately, today incumbent upon us is also this sustainability aspect. So when you talk about aluminum, we have to be clear. Virgin aluminum, for example, can take up to 10 times the carbon footprint of steel. Recycled aluminum, significantly lower. Therefore, it would become a no-brainer for somebody to say, oh, why don't we use recycled aluminum? But then, and Ritesh would hopefully agree with me, the supply chain to manage a steady flow of aluminum of the right quality is still something that's going to take a little bit of a time. So many of these materials are on the cusp or on the threshold of being able to have extremely useful commercial applications, but in some cases they may be limited by a certain number of supply chain issues or availability issues, and all of these factors need to sort of come together in order for a comprehensive solution to be available. I think with each passing month, passing quarter, we make progress towards it, and that is really the challenges that we all try to solve together as a community.
Right. And Sarvar, I'll come to you with that, and I'm glad Anand brought that up. You know, the supply chain factor in all of this. I mean, what are the challenges there, and what do you see? I mean, what's the roadmap that you see going forward? How are we going to see the evolution of the supply chain when we're talking about all of these advanced and new generation materials towards lightweighting?
So Mayank, as far as steel is concerned, I think when we started way back in 1960, we had only 5 grades of steel. Today, we have more than 175 grades of steel. And that's how the steel industry has evolved over a period of time to give you the most balanced structural strength that you require with different kinds of application needs within the vehicle.
Right.
So a lot of advancement has happened in the steel industry, and a lot of ecosystem is available on the steel industry in India.
Okay.
We are able to do up to 980 megapascals within India. Beyond that, when it comes to 1150 kind of tensile strength and even beyond, which is ultra high strength steel or advanced high strength steel material, that is not available in India because it doesn't have the economies of scale to produce in India. It's not that the technology is not present, because we have ArcelorMittal in India, we have Tata Steel, we have JSW who have the technologies, but it's very difficult to produce it in India with the economies of scale that we have.
Right.
That becomes a limitation in terms of localizing the advanced high strength steels that we now are migrating to with the increased CAFE requirements. And that's where I came to that at this point in time, wherein you have to actually switch to advanced high strength steel material or more exotic material in the terms of carbon fiber composites or glass fiber composites. There's no availability in India. And that's where the nearest is aluminum. And even in aluminum, if you look at it, most of the aluminum is imported. It's not available in India. And most of our aluminum requirements are either imported from Bahrain, Middle East, these kinds of countries.
Okay.
Yes, the recyclability of aluminum is there, but to an extent and not beyond that. Anand was quite correct over there. When it comes to magnesium, we have the issue of scrap recycling. Because it's a very flammable material, you can't recycle, and we don't have those facilities to recycle scrap of magnesium in India.
Okay.
So interestingly, while we have started using magnesium steering wheels for the last 5-6 years, there's no availability of scrap to be recycled, and hence the scrap has to be exported out.
Okay.
Even to be exported out needs a sufficient tonnage.
Correct.
So the guys who are actually producing magnesium for us in India are storing the scrap at their place till the time the quantity goes big enough for them to export it out to US or other places to recycle. So this is a huge challenge to counter. The other challenge is, since most of the material which goes into lightweighting, advanced lightweighting, if we call it, since the supply chain is all dependent on countries outside India, there's a huge risk to it. The risk is because our volumes are uncertain. Many a times we do not have consistent volumes. We will land up with excess material or a shortage of material. And hence, there's a cost to keeping inventory. And if you're keeping the inventory, there is always a risk of obsolescence.
Right.
So that's the challenge that we see on the supply chain when we go to materials of choice to have advanced lightweighting in the vehicles.
Right. So basically, right now, the biggest concern that I can understand, Mr. Agarwal, is the economies of scale that is required for some of these advanced materials.
Exactly.
Right. And Mr. Srikumar, so your thoughts, I mean, I want to understand here, I mean, like Mr. Agarwal mentioned, that some of these regulations will definitely drive a lot of OEMs to use these materials so that, the economies of scale kick in and you're able to localize these materials. But tell me, I mean, is it going to be the entry level? We're talking about the passenger vehicle segment here. So is it going to be the mainstream, the entry level space, the small cars that we have, the majority of them on our roads, that is going to use these materials, or is it to be driven from the top end, the SUVs, the mid-size SUVs, like in Mr. Agarwal's case, the XUV 700 or the 300, those sort of vehicles. So, I mean, if you could just make me understand, how are we going to see this pan out?
Yeah, good question, actually. So let me explain from the point of view, maybe explaining with an example. So we have carbon fiber, say, glass epoxy material and Kevlar. That is also one of the composites, right, which has got strength. So if you're looking at the weight comparison between them, for a plate with 1 square meter and 6 mm thick, the steel gives 47 kgs, aluminum gives 16 kgs, whereas carbon fiber gives just 9 kgs. The cost of carbon fiber is around $21.5 US. If you go to epoxy, the weight is totally 11.4 kgs. Remember, all these are replaceable among themselves because they have a very high strength, good flammability, I mean, thermal resistance, structural resistance, etc., structural strength, etc. And if you look at the cost of the glass epoxy per se, the cost per kg is around $3 only. Whereas in Kevlar composite, this is at some point of time, I do not know the current rate. But if you look at Kevlar composite as such, you got around 8 kgs as a total weight, whereas your cost per meter is around $29 US. So we can see the cost is very high, and we are going to replace some components which are as common as a roof, which is currently being used. We're going to use a composite there. Obviously, there is going for, because you have a you need to do some rollover test or intrusion test. whatever is the regulation that requires you need to have high strength material in those areas. So obviously, when you are going to replace that, the cost is going to be high. There is no doubt about it. The cost will be high as far as replacing the existing component is concerned, and you cannot go into low cost cars or entry level costs at all. It has to be it has to start from top down. Basically, that is what it is. And very rightly said, there are a few points which I want to add, which could help in supply chain issues as such, is that you can, when you are looking at all these new materials and you're going to apply them, somebody has to certify that material is okay, and so that materials can be used for that particular application. And because that is going to get into some sort of a regulation, it could be a critical component for the regulation or whatever it is, correct? So the testing labs has to be established everywhere, and there should be procedures and processes that needs to be given to them such that the material is certified as okay to be used there. Because all these materials, if you look at it, every individual OE supplier is going to have a IP rights on that. So it is not going to be prevalent everywhere, and everybody is going to bring in an exotic material type, which is going to really stress the market in terms of cost. And also, not only that, the testing part is what everybody has to look at. So if you're going to, if it goes to a different country, how are you going to make sure that that particular country's regulation is met when you're using this particular material in that particular component? So this is also something that has to be looked at. And there should be some sort of an movement wherein all of us can get in together, like industry, academia, as well as the suppliers can get in together to break this jam, so that we can get into the entry level parts. Until the entry level parts are there, the mass market is not going to be there. So your usage is not going to be that much, or the effect of whatever the material you're going to use is not going to be effective if it is going to stay with only high-end cars. If you want to use it for the lower-end cars, you need to make sure it is available to the material is cheaper, easily available, and everybody is it is replaceable, and everybody will be able to use it.
Right. I'll take that to you, Anand. I'll still want to get some more details on it. So, even in your portfolio, you have cars ranging from the Tiago all the way to the Safari. So, very different platforms, very different price points. So, what are the parameters when you're looking at these materials? We're talking about the ultra high strength steels here. So, which still, like Mr. Agarwal mentioned, they're still being imported in India right now. So how do you come across to take this decision that whether you'll be able to go with that material in a particular platform or not? So if you can explain that to me.
It is really a choice that we have in terms of how we would want to implement this entire thing. And while India does have the ability to go up to a certain grade of steels, certain other grades of steels, and because as a development team, you always have a conundrum of whether you want to go the entire way out and build it into whatever could be the least weight, although with a certain high level of cost, or you would want to keep the cost in control. And it is typical that when you are in a competitive market, the cost always has to be borne in mind. So you would, as a development team, always want to use as less grades of steels which are not available here, because you wouldn't want to open up the risk of a supply chain issue. And that again is a limiting situation in a way, because then if you're limiting the amount of the steel that you're using, depending upon the volumes, you get into an issue of how much steel do you bring in, because you then have to look at protection, and you then have to look at making sure that it gets consumed, etc., etc. So these are issues that you have to deal with. This is certainly one part of it. To counter that, what people do is find alternate solutions.
Yeah.
And these alternate solutions can sometimes, funnily, be in terms of slightly lower grades of steels at a slightly higher weight, in fact. I mean, we are talking at a lightweight conference, but these are real compromises that have to be made. And therefore, I always say that the availability of scientific knowledge is not the problem. The ability of that scientific knowledge to be deployed to a real life solution and to be done in a more consistent manner is the challenge that we have to solve. And therefore, this is the reality of the challenge that we come upon to face. And therefore, these choices have to be made with a lot of care, with a lot of thought on how things are going to pan out in the future and what will it mean. And like we said earlier, it's all about obsolescence, inventory management. And for example, in some cases, and I'll give you a very live example. If you look at the safety norms which are evolving, you have a side sill impact or a lateral impact that the car, a pole impact, let's say, that the car has to sustain. Now, it is different in a ICE car and it is different in a electric vehicle, because just beyond that sill of the electric vehicle is the battery, and you do not want to have any incursion of forces within the battery. Therefore, you need that sill to be extremely strong. Now, could we not make that sill strong? Of course, you could make it strong, because you could just add metal, add sheet, and you could add the metal of the right level. But that means mass on a car that you already are trying to reduce, and therefore you would ideally, as engineers, want to design a structure which is light but at the same time capable of not crushing so quickly. And honeycomb structures or some sort of extruded form of aluminum or some lightweight material offers a great solution. Then the constraints of whether you have those manufacturing facilities, whether you have those materials, whether you have those in enough quantities, whether you have volumes, all of these come together. And then whatever is the most plausible solution has to take forbearance. It has to go forward. And that's how the decisions usually get made. And I think while this is a flow of a decision making, it happens for almost each and everything that we do.
Right, right. And I'll come to you, Mr. Agarwal, on that. I mean, we're just talking about being innovative here in terms of your design approach as well. Being from sourcing, I think there's a lot of VAVE that also happens. So, from your perspective, from that side, can you give us some examples wherein you've seen, just by doing a simple cost cutting or, VAVE, you're also able to reduce the weight of the vehicle in a certain way?
It does happen, and that's most certainly which happens when you go for high strength steel. Going from a plain mild steel, if you go to a high strength steel, you are able to reduce the gauge of the material and achieve lightweighting as well. Hot stamping is another technology which we have used in the past. It's not exactly a value engineering, but this is a technology we have used extensively to achieve lightweighting, because it offers you a great structural strength and not at a very high cost. We have developed the supply chain on it, and we have extensively used it. Along with that, we have used the tailor welder technology. Now, when we use the tailor welder technology, we are able to combine different grades of material. We are able to combine different thicknesses of material. And while doing that, we can create one integrated structure and stamp it out in one process. So we are able to create reduce the number of parts, let's say from 20, 30, let's say in an inner ring kind of a structure, down to only one part and stamp it in one shot.
Right.
These are the ways you can actually counter the increase in cost which happens because of the choice of the material.
Right.
So an intelligent choice of material intelligent process along with an expensive material that you used, but for the application of getting the right strength in the car. So when you're talking earlier about an entry-level car versus an SUV kind of a vehicle, the difference is actually the safety requirement.
Right.
If you want to put in a safety requirement in a low-end car also, then you still need to have a high-strength material, a lightweighting along with it. So these are the things that we are done. But other materials also, like Anand Kulkarni spoke about honeycomb material. That's another way to achieve cost reduction, which we have also used extensively. These kinds of honeycomb material give you a weight reduction to a big extent, as well as give you cost reduction. If not an extensive cost reduction, it's almost at par. So we've done those kinds of things. There are other things also, like integrated parts in the engine technology. As the engine technology is progressing, what we've seen is by integrating, let's say in an oil cooler or an engine oil cooler, we have seen that if you're able to integrate many parts and get it in one shot, then you're able to reduce the cost. So things are evolving quite a lot, and they are giving us a cost reduction.
Right. Understand. Now, Anand, coming back to you, particularly in case of EVs, like we were just discussing, moving from 12 volt, which is the fundamental, to now 48, 72, and even further the high voltage EV architectures. So I mean the weight of the wiring harnesses also is one of the substantial, you know, components in contributing to the weight of the overall vehicle. So how about that? You know, what innovative thinking are we seeing there to sort of reduce the weight of this electrical E&E architecture?
So that's a very good question, and thank you for that. And that hopefully I should be able to explain that a little bit further, because it's not only about the ability to do lightweighting by going to a lighter architecture or a lighter use of copper, but it's also something that we have to look at how the end use case sort of comes up and gets explored. Uh, Typically, it's all about the voltage system. You rightly mentioned low voltage systems versus high voltage systems. Today, uh, the premium cars and increasingly even the mass cars are starting to go to higher and higher voltage architectures. So, just for the sake of technical clarity, anything that is 60 volts and below is classified as low voltage. Anything that is 60 volts and above is classified as higher voltage, because of the amount of damage or amount of injury that can be caused to a human body. But colloquially, while that be the case, anything that's around 300, 350 volts on electric vehicles starts to get qualified as high voltage vehicles. Now, in order for a certain amount of power to be generated or power to be utilized by the motor, you need current and you need voltage to go with it. Therefore, if you are lower on the voltage, you will need to compensate it with higher currents, and higher currents often mean higher diameters of conductors, and that often means heat, so on and so forth. There's also losses. So people have been experimenting, and today, as I said, the premium cars are more like 800 volt systems. And the moment you do that, you are essentially going into a very high performance zone as well. But let's say performance staying where it is, you could technically reduce the current that needs to pass to the conductors. And that certainly has the opportunity to reduce the size of the conductors from a diameter of the wires. We've seen typically that a doubling of voltages can reduce. Now, let's understand one parameter has to be held constant, and that's the performance or the power. But therefore, you can certainly reduce on the amount of copper within the vehicle, and it's depending upon how you lay out the architecture, it's possible to do roughly around 40 to 45% reduction in copper alone. More importantly, you could also substitute that with, let's say, more lighter or less expensive materials also, like aluminum, for example. Of course, that has to go through some other durability expectation and so on and so forth, or flat wiring harnesses, etc. But these are methods that are currently being evaluated by people, and I'm sure as we go on, because of constraints on the integration aspects as well as constraints on cost or challenges on the cost is how I would say, you will see more and more of these things happen. Why I said about the other aspect that has to be looked at is, for example, it's easily possible for us to go to a high voltage system, but then high voltage system would mean that you have infrastructure to be able to support that on the other side so that your cars can get charged and so on and so forth. So it's a toss up. It's a toss up, and I think all things have to move at a common pace. Sometimes a couple of things can move a little ahead so that the rest of the things can catch up. But it cannot be that you have a great vehicle and in order to go charging, you have to go on a standard old archaic system. So infrastructure improvements also have to keep pace.
Right, right. And there's also this talk of, you know, the zonal ECU architectures, Anand. You know, I mean, you're going from independent ECUs for each of the functions to now a centralized setup or a zone-based setup. So, you know, is that also going to contribute to weight reduction?
Oh, yes. So essentially what is happening is as the amount of electronification within the car has gone on increasing. See, look at what's happened over the last 40 years, and the amount of sensors and amount of actuators within the car have grown significantly. Now think of this as if you would have given an independent controller and an independent brain on each of these actuators, you would have a large amount of electronics. But the smart automotive engineers that everyone is, we've tried to combine everything and said, why don't we dump down the actuators and keep the intelligence at a central location? And that's the zonal architecture that we are talking about in very simplistic terms. And that then allows you to sort of get agnostic with actuators in a very colloquial way. And but that also gives you the opportunity that you do not need to replicate functions. You do not need to replicate create more network in terms of physical wires or things of that sort. And that's the kind of improvement that happens. Of course, this is a wave. So very often what happens is sometimes it increases the mass because we are talking only about mass, but it increases before it comes down as more functionality, as more processing power gets built.
Right. Mr. Srikumar, your thoughts. I want to get your thoughts also on that, about this, the centralized computing that we are increasingly seeing, especially with EVs coming in. So is that the way forward, and is that also going to be a key contributor towards weight reduction?
Actually, yeah, that is true. And if you're looking at it, they are combining now the ECUs, having 2-3 functionalities, and also they are looking at, say, the form or the materials that is being used to keep the number of, basically they want to keep the number of ECUs less, so which will basically improve the lightweighting and also have better control. So yeah, that is true.
Sure. And Mr. Agarwal, from your standpoint, sourcing side, I mean, how does it become more complex for you, or is it becoming more easier for you to source just one sort of electrical centralized CPU for the vehicle rather than individually sourcing different devices for each of the functions?
Zonal versus a distributed network, zonal is definitely an improvement step, not just from a lightweighting perspective, but even from a supply chain perspective.
Right.
Because even if you have 10 different ECUs to manage, like one ECU for managing, let's say, the door items, one ECU to manage only the let's say the cockpit domain system. So these are very difficult to manage because there are so many more components in it, so many more ICs. Whereas if you move to a zonal ECU, you're combining, let's say, an ABS ECU, you're able to integrate the door system modules in it, reducing the amount of hardware which is packed into it, reducing the amount of supply chain which goes into it. So it's a welcome move in that direction. We have to only focus on one component.
Right.
With advanced technologies, we can go for high performance compute over there to counter the issue of the requirement of the computing power. And that way we can still manage it. But it's a move in the right direction to have a high performance compute or a zonal compute, which reduces the number of supply chain complexities.
Sure. And I want to direct one question from the audience, Mr. Agarwal, to you. This is from Mr. Joel Johnson. And he says, would an OEM be more interested in applying lightweighting using lighter materials that have a complex supply chain, or tend to use advanced manufacturing techniques in the BIW or the body shop or vehicle design, like using spot welding instead of the fastener? So what would your approach be towards it?
It's a combination of things. No one process is good enough. It has to be an application of unconventional material in the form of ultra high strength steel along with a good process. When it comes to using a mix of material between aluminum and steel, then you have to go with the processes that are suitable to it, which means you have to go with the riveting technology. If it is aluminum, you can go for a welding which is suitable to that particular process. When you go for a hot stamping material, again, you have to use the material the process which is suitable to it. So it has to be a mix of the two. But having said that, it's not a huge challenge to manage the supply chain for material which are still imported from outside. We've been surviving that for quite a few years now. We have learned the technique of managing the supply chain, and we will be able to do it. Yes, there is a cost associated with the imported material that we have to counter, and that's where we have to encourage the industry to the use of unconventional material in the form of plastic composites or be it aluminum, and that way. And as the usage increases, I'm sure the industry will respond in terms of producing it locally. We've also seen the support of Indian government in terms of putting up a BIS requirement in the kinds of material that we are coming from outside. We are pushing the local supply chain to work on localizing the material, especially aluminum. Why can't it be produced in India? Things like alloy wheels. Why are we importing the material from outside? We should be sourcing it from the likes of Vedanta and Hindalco. Now, coming back to the process part of it, spot welding is a very natural process which we've been using for ages. Now we are going for cold metal transfer kind of technology, but that technology is applied where it is required. So it is an optimum use of the process where it is required, I would answer. We will not use a process which is not required for a particular material.
Right. We have to take a balanced approach and, deploy multiple processes to arrive at the optimized level. Right. Anand, coming back to you, we recently, drove the Punch EV, and, in that also you've done some very unique, you've taken some measures to sort of stiffen the chassis so that, the battery weight could be taken by the chassis and you're able to tune the suspension better. So could you take that example and sort of elucidate our audience on that, what exactly that approach was?
Thanks, Mike, for that question. You are right. The Punch EV is indeed a platform that we've been able to articulate in order to improve the overall torsional stiffness. And that bears the approach because of the Gen 2 kind of architecture that we have, where the battery is designed in such a way that it takes some sort of support as well as gives some kind of robustness, rigidity to the entire floor. As a result of that, what happens is the floor torsional stiffness increases, which therefore means that you can go lighter on the material, the number of the panel count as well, because it simplifies a lot of things. More importantly, it also allows you to not be able to or not need to control the wheel displacements through if the chassis were not stiff enough, you would have to compensate some part of that. Here, because the entire floor pan and the chassis is very stiff, it allows you to go softer on the wheels to a certain extent, and that manifests itself in terms of great ride comfort, even on undulating roads, as well as a less amount of roll as the vehicle negotiates or maneuvers through turns. So I think it's a great balance that we've been able to strike, and it's largely on account of the architecture that we've been able to design, which is not only increase the torsional stiffness by about 30%, but also reduced part count by about 15% and reduce the weight by about 7% for the entire floor pan.
Right. And there's one more element that I want to bring up, Anand, this sunroof. So I think from the marketing side, there's a huge requirement now, given the penchant for sunroofs in the Indian market. And, Mr. Agarwal would also be sourcing a lot of them right now. So, but, from an engineering standpoint, Anand, it's adding weight at the wrong place in the body in white. So how do you counter that? I mean, how are you managing that very unique challenge right now?
Well, I think the automotive area per se is an extremely passionate area. It's a passionate field, Mike. You and I know this more than anybody else. And therefore, if you have to do it for the sake of passion, then I think as engineers, we have to find solutions which can meet that. We do a lot in terms of making sure that the stiffness of the entire structure is good enough. You are right, it does move the weight up a little bit vertically upwards. But let me tell you, it also adds a very high element of stiffness to the roof, which therefore means that the drumming frequencies get shifted significantly upwards, and that's an improvement on cavity noise. That's an improvement on drumming noise, and also as the car moves on slightly rough granulated surfaces, the kind of secondary vibration induced noise that you have is lower, and therefore it's again a balance. But I think let's keep the engineering out of it. The fun that people have out of a sunroof, I think there's nothing to beat that.
Right. Okay. Mr. Srikumar, I'll throw one question from the audience to you. This is from Mr. Kishore Deshmukh. And the question is, how can we make use of biodegradable renewable materials in automotive? I mean, he's asking particularly about bamboo, which has high strength and will help in sustainability. So how can we use that in automotive application?
So particularly for bamboo, I think if I recall it right, it can be used in the seat fabrics, wherein people are trying to experiment with multiple of materials, which gives us a comfort. And it is one area where the bamboo can be used actually.
Okay. Any other places you see, I mean, it getting deployed?
So they are trying to basically getting into a structural part using bamboo again as a fibers. These are something which I recall very sometime back, but I don't think these are still under research basically, where they want to use as a structure,
Right.
but it is in the more of a fiber form than actual bamboo itself. So that is.
But what about biodegradable materials, Mr. Shikumar, in general? What sort of different materials are we going to see being adopted in the future?
Yeah, there is little information from my side at this point of time on that, but I can get back to you on that question.
Sure.
I can take it on that,
Yes,
Mayank.
please. Yeah.
Some of the biodegradable material, today the foam is purely synthetic that we are using, right? So one of the biodegradable usage is in using some of the oils which go into soya oil or whatever kinds of oil, which goes into foam technology. So that is one application of usage of biodegradable material into foam. The other one is in plastic composites, the kind of fibers, normally like we have glass fibers and all, which are not exactly recyclable, that kind of a material, that composite. But I think there are cellulose fibers. I mean, work is going on cellulose fibers getting integrated into plastic composite. That will again make it more biodegradable. So these are the two applications which I'm seeing on the biodegradable standpoint. Coming to plastics, which go into the interiors of vehicles, they're also not the A surface plastics, but the B surface plastics use some of the natural material which are available. That also helps in, one is in lightweighting it and also in making it more sustainable plastic.
Right, absolutely. And there's another question, Mr. Agarwal. I mean, it's talking more towards the process side. So are there any special processes that Mahindra is going to adopt in its future line of EVs? I mean, that help towards lightweighting and obviously towards sustainability?
One is I talked about on the body structure side, which is
Right.
increased usage of hot sand material.
Right.
That is something which we are not able to find a substitute with, because that gives a lot of strength to the parts, and also it is easily manufacturable with the kind of infrastructure that we are developing in. So that is one thing that we are going to increasingly use. The second one is, as far as the battery frame is concerned, we already migrated from steel to aluminum. And that is giving us a lot of weight advantage. What we've seen is in the older generation EV that we've done, which was in steel, we were having 150 child parts. When we migrated into aluminum, it has given us a weight reduction also, and it has reduced the complexity of manufacturing the aluminum frame. These are the two technologies I can talk about. I mean, higher strength steel and aluminum, which are going to increasingly penetrate into our vehicles.
Yeah. Would you also want to comment on giga casting that Mr. Raman mentioned in his presentation? I mean,
so we are aware that Tesla has done it. Again, it requires a scale of volumes.
Right.
Tesla has done it because they could command that much of volume or anticipate that kind of a volume in the industry. Once something of that sort happens in India, then probably people will think about it. But as of now, I don't see anybody looking at that kind of an option because of the capital which is going to get invested into creating that kind of an infrastructure. It's not available in India as of now.
Right.
And
I think cost.
Mayank, I might want to add to what you said. Giga castings, you rightly said, was sort of innovated by Tesla, but today you have this as a very, very common technology in the Chinese market. Almost all the large car manufacturers in China have shifted, large EV manufacturers have shifted to giga casting. But very important to understand that you need to A, have volumes, B, you need to also be prepared for frequent tool changes. C, you need to also look at what are the servicing aspects, because ultimately at the end of the day, it's a casting. In case of an accident or in case of a damage, how are you going to manage this?
Yeah.
And fourthly, which is not an external problem, but which is an internal challenge that one would have, is how do you deploy your facilities? Because aluminum and steel, the paint processes and the paint criteria are different. And therefore, if you once you start to have more aluminum in a structure, you need to make necessary changes to the paint shop at your end. And that paint shop could often mean that you need to have a separate facility depending upon the content that you. So, in a place or in a market like ours, which has to thrive on cost efficiencies, replacement efficiencies, our turnaround times of vehicles is very high. We don't discard vehicles very quickly. They go through generational use, although they might not be with the same owner. There are multiple aspects that we as a country need to look at before adopting, just because it's been adopted in some different market as well. And I think this awareness also has to be created.
Right.
So I have one more point actually on the process, which I recently came upon. Pretty interesting. We know that studs are being welded to steel material and it is being used for assembly, right? So when you are using aluminum or HSS steels, you can't use the same steel because the matching component and the torque requirement cannot be changed. So what I came across is a new process, something called stud gluing system. So this is something I read and very interesting. And yeah, I thought I'll put it across the table for you.
Sure. No, thank you very much, gentlemen. I think we have run out of time, but I really appreciate each one of your thoughts and your specific expertise that you brought to this discussion, right from sourcing, Mr. Agarwal, to design and engineering, Mr. Shikmar, and similar for you, Anand. Really appreciate all the inputs that you've brought and help our audience understand about the different measures of lightweighting in automotive. I think if I can summarize it in a way, it would be like, you have to always take the most prudent approach towards this, simply because India is a very cost competitive and a very cost and conscious market, and anyway capital is always limited, so you have to always be very wise in your investments and your return on. So really appreciate your time. Thank you very much, all of you. Thanks a lot.
Thanks, Mayank.
Thank you for the opportunity.
Thank you.
Thank you.
Thank you, panelists.
And with that, we'll move to our final session for the day, which is an interview with Mr. Sushil Mane. He's the technical director from software solutions company Altair. Mr. Mane he specializes in technology and customer support, as well as simulation and design support at Altair. And our conversation would revolve around the integrated design strategies for lightweighting in vehicles. And all of us are well aware that Altair is one solutions provider, which is sort of the go-to product when it comes to optimizing weight in your platforms and doing lightweighting in your vehicles and automotive products. Mr. Mane, thank you very much for joining us and taking out the time.
Hello, Mr. Mayank. Very good evening.
Yes, good evening. I'm unable to see your video. Is your camera on?
Yes, I have my camera on. I'm not sure. There is some issue from my side. Apologies. I think there is some issue from my side.
Man, can you request Mr. Sushil to log off and log in again, please?
Yeah. Mr. Mane, if you could just join in again, just please log out and rejoin once.
Sure. Let me try that.
Yeah, maybe that solves the problem.
Okay.
Yeah. So in the interim, I would like to mention it to our audience that, whatever discussions you've seen so far over the last 1.5 hours, everything will be available after this on our YouTube channel. We'll publish this webinar as well for your future reference. And this is not a certification course as such. So I'm getting a lot of queries in the Q&A box that whether you'll get a certificate for attending this webinar. No, it is not a certified course as such. This is just our initiative of bringing experts from the industry to guide you better on this important topic like lightweighting, and similarly we do other events as well. So that is what our endeavor is here, to sort of bring experts from the industry. Some of these people you've heard some time back, they are at very senior levels at various OEMs and component makers and technology companies within automotive. So that is what we strive to do, to make you learn and to deliberate and discuss upon these things which might be challenging in your day-to-day tasks.
Mr. Mayank, can you see me?
I am unable to still see you, Mr. Mane. I think there's some problem here. Naveen, could you help us here? If there's anything else Mr. Mane could do?
Just a second. Basically, the thing is, his thing is not getting. Just a second.
Mr. Mane, are you doing this from a laptop or a...
Yeah, it's from a laptop. Yeah.
Oh, okay. Can you try this from your mobile phone if that is all right?
Okay.
Man, can you just start this session? I'll look into it, please.
Yeah, sure. Mr. Mane, there's no camera cover on your laptop, right?
No, it is not.
Okay. Maybe just try on your phone. You have the link with you on your email that I've shared with you.
Let me check.
If you could just try logging in from your phone, maybe that helps us.
Okay.
Mr. Mane, hello.
Yeah.
Mr. Mane,
Okay.
can you hear me? Because basically when you log in, you have an option that use the computer audio and video.
Yes, I did that. Could be some issue with my laptop, I believe.
Yes, so I think so. So we can just have a voice conversation started.
Yeah, we can even do that.
Mr. Mane, could you log in from your mobile device?
Yeah, I'm doing that.
Yeah, sure.
I'm sorry, this is going to take some time, I believe. So it's asking the meeting ID. Mr. Mayank, can you let me know what is the meeting ID?
Okay, just a second. My last email to you, Mr. Mane, I mean, that has the Zoom link.
Yeah,
So
I
if
have
you
that.
Yeah, just click on that link. It will straight away allow you to join into this meeting.
Well, I did that, but it's still asking the meeting ID.
It's asking you for a meeting ID. I'm not sure. Okay, that's fine. I think we can just continue the conversation, Mr. Mane. I think we're really sorry, everybody. I mean, seems to be some sort of a technical glitch here that we are unable to resolve. But nonetheless, Mr. Mane, it's just your, thank you very much for your time and joining us for this event. Broadly, your thoughts on, design and design strategies when it comes to lightweighting, because you represent Altair, and everybody knows that, Altair is one of the key solutions that empowers designers and engineers to sort of reduce the weight in different components or the platform or the vehicle as a whole. So your broad thoughts, what do you believe are the key measures when it comes to design towards lightweighting?
Yeah. First of all, I think I should thank you and the rest of the Autocar professional organization for inviting us to be part of this whole conference. So coming back to your question, I mean, definitely tools in the past did not provide such opportunities for designers, right? Not only, let's say, to look at just component level, but full vehicle level, right? But nowadays, if you look at some of these workflows that have been developed, not just Altair, but a lot of other companies, you see a lot of lightweighting strategies that can be developed upfront in the design process, right? Again, not just for component level, but even for full vehicle level strategies. So the whole impact that this upfront design process, right, with a lot of optimization thrown in, provides a huge opportunity for engineers to lightweight their structures, right? And then definitely, apart from a lot of these core development tools that have been developed, a lot of automated as well as semi-automated processes have been developed. And these basically help engineers to look at various strategies to come up with new vehicle programs, right? New vehicle structures, taking into account various kinds of load cases, different types of materials that they can explore, and so on. So definitely, I think at the current stage that we are in, there are so many different, let's say, tools and techniques that engineers and designers can use to lightweight their structures. So we are in a great stage today, and hope these can be used by multiple engineers worldwide for that.
Right, right. So in general, Mr. Mane, so what sort of uses, I mean, what sort of implementation or use or deployment of your solutions do you see in the automotive industry, if we specifically talk of the Indian market?
Yeah, so what we've been doing, especially in the Indian market, is to look at implementing some of these lightweighting strategies, which mainly use a lot of these optimization techniques, right, in the core design and simulation workflows, right? So as and when engineers start evaluating their designs, right upfront from their design processes, tools like topology optimization, to be very specific, are one of the key utilities or programs that engineers can use to lightweight their structures, even taking into account, let's say, a lot of these design targets that they have to meet. And apart from that, a lot of these manufacturing constraints that they have to actually work on. So these workflows that have been implemented in their everyday workflows that they have been using to evaluate their designs, you can use a lot of these topology optimization workflows to lightweight the structures. And of course, there are a lot of other tools that also fine-tune these designs. So in fact, the kind of outputs that topology optimization actually generates is like very crude in nature. So you will have to really use some very nice design interpretation tools, right? So these workflows have been part of the simulation platforms that engineers have been using. And these, in fact, help engineers to quickly interpret the design and make it much more, let's say, workable, so that they can fine tune that design and make it much more manufacturable as we move on, right? So that is really helping much.
Right. And in fact, in the question and answer box, we have a question, I mean, a comment perhaps, from Mr. Mohan. Like you mentioned that, we have to come to a point wherein the design is also manufacturable. So he talks about something like a tailor welded blank for sheet metal parts like doors. So is that something you're increasingly seeing being adopted in the industry?
Yes, Mank. So definitely such requirements are coming up from especially all the engineers who are using or implementing sheet metals, right? And of course, tailor welded blanks is one strategy that you can basically use to lightweight structures and also make it much more manufacturable. So to help engineers to actually use or implement such tailor welded designs, there are workflows which use a very specific term that I can use is what we call as free sizing optimization, right? And what that typically does is, given a constant thickness sheet metal, right? When you impose all these loads and boundary conditions for the structure, you can request from the optimizer to develop a much more tailor welded design, right? So what it eventually helps you to do is look at how you can drop down the thicknesses of these sheet metals and make it much more manufacturable. So on one side, while you have maybe a higher thickness, as you move towards the other side of the product, you see the thickness reducing. and you can definitely manufacture such type of parts. So a lot of these workflows are getting implemented as we talk in different organizations right now.
Right. And another key aspect of this entire exercise, just the engineering of a product in general, Mr. Mane, is, lightweighting, and also at the same time, you better your product on safety, like crash worthiness, for example.
Right.
So how is that being solved right now? How is that critical problem being addressed as of now in the industry?
Yeah. So as far as looking at the crash worthiness of a structure in the design process, and looking at even how optimization workflows check for the crash worthiness of the structure. Of course, upfront in the design process, the current optimization tools do not much support the non-linearity of what crash worthiness actually looks at. We basically look at linearization of these loads and then trying to arrive at that optimal design using topology.
Right.
But as you fine tune your design and then move downstream, there are definitely a lot of these multidisciplinary optimization workflows, right? So you are not only looking at crash, but even evaluating your designs for durability and NVH, right? And definitely these MDO workflows look at various responses for crash and evaluate your structures for crash. So it basically tries to get a balance of your design for crash, NVH, and durability, and fine tune your design as we move forward. Right. So these are some of those workflows that I can think of. Yeah.
Sure. And Mr. Mane, we are today in this era of artificial intelligence. So is that also increasingly being built in the Altair platforms as well? For example, if an engineer is assessing the platform for its crash worthiness, or for topology optimization, so is there also some sort of a direct feedback directly from the software that he or she is using, so as to what could be the better way to do that particular area?
Yes, definitely. We are actually looking at such kind of implementations in the simulation workflow. Now that there is so much of AI coming into our world, Altair has invested a lot on implementing these AI workflows in the engineering process, right? And what we have done is a couple of those implementations are basically looking at using what we call as physics AI, right? The whole idea of having the past historical data of simulations that you have done, and then reading that data set to actually develop a predictive ML model, right? And of course, these predictive ML models can be tested for their quality and so on. And then once you have a good quality predictive model, you can in fact use that for subsequent, let's say, iterations of the design, or maybe to evaluate a new concept or a new design, right? So these physics AI workflows that Altair has implemented, of course, uses a technique called as geometric deep learning, right? This is one such that I can think of. But one very key aspect, especially with regards to the crash worthiness, is what we have implemented within Hypermesh, of having to actually read a data set of simulations that you have done and look at so it basically draws in data sets, right? So you've probably done, let's say, huge amounts of simulations in the past, right? And then when you read in such simulations, what we typically try to understand is how are all these designs behaving at different design points, right? And when we actually post process this, it kind of becomes very difficult for a young engineer to interpret such very complex results, especially with regards to crash worthiness. So it then is part of a very expert from the crash domain to look at such results and then identify the key response or the key behavior that he expects from a design, right? And therefore, we have implemented this unique AI technology called as expert emulation, right? Of having to actually use an expert's recommendation of what should be the ideal behavior of a crash simulation, right?
Right.
And once you train the model based on the expert emulated suggestion, you can then, let's say, look at new designs that you are trying to evaluate, and then identify whether these are falling into the right behavior or the wrong behavior, right?
Right.
As far as crashworthiness is concerned. And
Right.
once that is getting trained, you can then use this trained ML model for even subsequent optimizations as well, right?
Exactly. I
So,
think that is what AI is going to bring, Mr. Mane. I mean, you have to train the model on your past designs itself. You're not going to go to other designs. You're going to train it on your
absolutely.
existing designs or the previous designs that you've done. And based on that, it's going to fine-tune your future designs that you're going to do, right?
Right, absolutely. And then, of course, the data that you have need not have to be just from simulations, right? You could probably have even test data, right?
Okay.
So definitely there are these AI algorithms built in to read in even test data along with simulation, right? And they can be used to develop these trained or predicted ML models.
Okay.
So based on use cases, based on the type of systems that we are evaluating, there are different AI workflows that engineers can use now. Yeah.
Okay. Right. And one more aspect that we've discussed so far in this webinar, Mr. Mane, is that is of the alternative materials like composites, and we're talking about ultra high strength steels and high strength steels, and also biodegradable materials. That we might see come up in the future. So how is that? Are you also able to evaluate such materials within the Altair solutions, or while you're doing this evaluation?
Absolutely, Mayank. So apart from metals, of course, these advanced materials that are being used nowadays to lightweight structures.
Right.
There is definitely a demand from OEMs to get, let's say, seamless workflows developed in the product development processes that they can use very quickly to identify the right, let's say, material composition. And especially with regards to advanced materials, these are very special materials, right? The behavior of these materials and using and getting the right quality of these material models is important, right? So we have workflows which basically help engineers to use what we call as micro mechanical simulations, much more of what we call as multi-scale simulation technologies to develop the right material models that can be used for all your simulations. And now once you develop these right quality material models from doing all these micro mechanical simulations, he can use that for either, let's say, the long fiber laminated composites or maybe the short fiber reinforced plastics that have been used. And then definitely when he starts running these simulations and then using these optimization workflows, there are platforms within the tools that Altair has developed, which will help him right from the early concept stage to identify, let's say, ply drop-offs, which are typical of laminated composites, or maybe identifying ply thicknesses or what we call as ply stacking sequences, right? Which are very typical of laminated composites. And these definitely help engineers to lightweight structures as far as composites are concerned, right? So those are definitely part of the workflows that are getting used in the industry.
Right. And what about manufacturability with these materials? I mean, is that also you're able to assess beforehand before going to final prototyping or even final production?
Absolutely. So the manufacturability of such type of special materials is one key thing. And right in that design process, while we are trying to, let's say, develop these material models, especially with regards to, for example, let's say, short fiber reinforced plastics, right? So while we are trying to develop this design by modifying the geometry of that particular design, we are also evaluating the manufacturability of these plastic materials, these special plastic materials, right? Which are typically injected, right? Plastic injection is the process that we do. And while we are actually running these simulations, we can definitely check and understand if there are any issues in manufacturing upfront in the design process. And also, once we are doing that, once we check for the feasibility of manufacturing, it also throws in a lot of other information which will help us to develop these material models downstream. So especially with regards to these short fiber reinforced plastics, the orientations of these short fibers are very important, and they play a huge part in the material behavior, the strength of the material, right? And those can be actually exported by the engineer to develop the right material model by using these micromechanical techniques.
Okay.
So yeah, these workflows are tightly built in, and so that engineers not only use design optimization but also check for the manufacturability of such type of materials.
Right, right.
Right.
And I also want to touch upon electrification or EVs. So what sort of different assessments are we seeing when it comes to an EV architecture or an electric vehicle platform? I mean, you were seeing we were discussing in the last panel discussion, there's a lot of E&E architecture that needs to be optimized as well. So what sort of different assessments or evaluations are we seeing when it comes to an EV?
Well, Manik, as far as the structure is concerned, definitely it changes with regards to how the powertrain has shifted from an IC engine to the battery powered engine, right? And the whole dynamics of the structure changes, right? So when we are designing a new vehicle program for an electric vehicle, we can definitely account for a complete change in the powertrain and the effect of that on the vehicle structure. So what we have developed as far as using some of these workflows is a very typical upfront design process that Altair has developed, what we call as C123, concept 1, 2, 3. And what this basically helps is to develop a vehicle architecture taking into account all possible loading scenarios. And that also pertains to even electric vehicles, right? So any OEM which is actually developing a new vehicle can come up with these new vehicle architectures taking into account all these different, let's say, simulations that he does for different load cases. And while he develops these vehicle architectures upfront in the design process, he also can fine-tune the design by using a lot of multidisciplinary optimization techniques, which is not only at a very localized level, but at a very full vehicle level. So C123 is a technology that we are seeing automotive OEMs using rampantly to develop these vehicle architectures for electric vehicles, and this has basically helped them to not only lightweight structures but even reduce the overall development time for electric vehicles. Right.
Sure. Now, Mr. Mani, I'll just switch to taking questions from our audience.
Okay.
So the first one is from Mr. Kishore Deshmukh. Can the AI data of one OEM be used for another OEM with different structure, topology, or topography?
Well, I don't know whether a different company can definitely use AI model built by another company. Definitely, they would not share that kind of data. And then also the whole vehicle architecture is different, right? The design methodologies, the design processes might be different in a different company. So you can't probably use a AI model built by a different company by another company, right?
I think it's a lot of copyright and
copyright
IP
issues, right? Right, definitely.
Correct. And there's one question from Mr. Swaroop Nalam, and this is about GigaCast that we were talking in the last panel session. So how is the Altair software basket helpful for the GigaCast technology?
Well, I think that's a great question. I happen to even be part of at the end of the panel discussion that you had a while back. So as far as mega castings or giga castings are concerned, very recently, close to around a year back, Altair worked with a well-known automotive OEM in Europe to develop a process that accounts for upfront, let's say, optimization processes that can be implemented taking into account the manufacturability of such large castings. And these also help the engineers to not evaluate for all these different load cases that we are doing, right? Whether it is durability, NVH, as well as crash, but also look at the manufacturability of that mega casting, right? So in the various stages of the design process, engineers can evaluate the manufacturability of that last casting, and this has been implemented in the workflow. So we have a casting simulation tool called as Inspire Cast. So in the process, while he's actually designing this mega cast, he can definitely check for the castability of that particular part. And it's not just one workflow that we are talking about, like topology, but a lot of different optimization workflows have been implemented in this mega casting or giga casting workflow, which also uses a lot of AI in the background, of having to look at a lot of DOEs that you have done, then use that data set from a DOE to build a predictive ML model so that you can reduce the overall runtime as far as looking at new designs and the behavior of these new designs. So a process definitely is in place for engineers to develop these large mega castings, which all takes the best of technology that Altair has developed, from topology optimization to checking for the feasibility of manufacturing to even using AI for predictions. Yeah.
Sure. And there's another question from Mr. Daniel Jelly. He wants to understand, is there any automation capability of Altair's Inspire Form platform to do mass part assessment or reporting in an overnight sort of a run?
All the tools, in fact, from Altair, whether it is the structural simulation softwares or the manufacturing tools like Inspire Form, are definitely open for automation, right? And if you are having a very specific need to really look at large formability of multiple parts in a system, you can definitely develop a workflow, an automation tool, which will run through all these different formability checks of multiple sheet metal parts, right? And then once these formability checks are done, we can also use the manufacturing effects that can be actually inbuilt into or maybe imported into a structural simulation as well, right? Because manufacturing effects has a huge impact on even the structural behavior, right? So an automation can definitely be built in so that you can import these manufacturing effects on a structural simulation, for example, let's say a crash or an NVH simulation, and see the effect of manufacturing on the structural behavior as well. So that can definitely be done. Yes.
Right, right. I hope Mr. Jelly has got his answer. And with that, Mr. Mane, we have completely run out of time. So really appreciate your joining for us here in this event and taking out the time. Barring the technical small glitch that we encountered, I think it was a fabulous conversation, and I hope the audience also were able to absorb a lot about, the assessment and simulation part of design when it comes to lightweighting. So really appreciate your time and thank you very much, Mr. Mane.
Thank you, Mayank, and the Autocar Professional Organization for giving us this opportunity. And I definitely am sorry I couldn't get my video on, but I'll
That's
make up hopefully next time. Yeah.
Next time. Yeah. Really our pleasure. Thank you so much, Mr. Mane. And with that, we have come to the close of the first day of the 2024 edition of the Autocar Professional Vehicle Lightweighting Conference. I think today we discussed a lot about the key drivers of lightweighting, wherein Mr. C.V. Raman, the former CTO of Maruti Suzuki, he touched upon how regulations are one of the key drivers of lightweighting, how sustainability is a big enabler of this engineering approach, and everybody is sort of working towards it right now. In the panel, we discussed about the different materials that are available towards lightweighting, the engineering approach, and the supply chain constraints, and how cost is one of the biggest factors that needs to be considered when it comes to designing your products while keeping in mind the lightweighting initiatives. And lastly, with Mr. Mane, we talked about the different assessment and simulation prospects of your design with respect to lightweighting. So really appreciate everyone logging in for the last 2 hours, and I hope everyone had a lot of takeaways from this. Tomorrow as well, we have a power-packed session lined up wherein we're going to discuss more on material technology and how materials are going to play a key role in the lightweighting endeavor. We're going to be inviting Mr. Glyn Jones, the MD of Gistamp India. We're going to have representation from Asahi India Glass, and again, representation from Tata Technologies and Ashok Leyland as well as from JSW Steel. So do log in tomorrow, same time, 3 o'clock in the afternoon, and we'll see you tomorrow as well. Thank you very much.